Hey, good afternoon, Honors Chemistry kids. I want to do a little bit of a practice with physical and chemical properties and also physical and chemical changes. So this is a worksheet that I have used with my Honors Chemistry class before. We're going to go over it together, and I'm going to do some very similar things on your homework assignment tonight. Notice also that I have put up some Quizlets for column 1, 2, and 3 of the elements for you to start memorizing the symbols and the names. I'm going to start quizzing you guys though. So you're going to start seeing quizzes put on Canvas for the elements here pretty soon as well. All right, here we go. Let's look at this first section. So on this first section, we have identify the following as either a chemical property or a physical property. Chemical with a C and physical property with a P. I'm going to give you a second. Stop the video. Figure out what's going on. Okay, have you gotten your answers for all of these? Let's go through them together. Blue color. Blue color is something I can observe without changing that material. So that is a physical property. Melting point. I'm not changing the material either. I am just, I don't want that to be here. I am just changing the phase, solid, liquid, or gas. Density. Also, I'm not changing what that material is. So that is a physical property when I observe the density. Whether it reacts with water. There's that key word there, reacts. That is a chemical property. Flammability or burning, once again, that is a reaction. So that is a chemical property. Hardness, or how hard something is on the Snell scale, that is a physical property. I don't change it by crumbling it. Solubility, whether it dissolves. Once again, I can dissolve things without changing what they are. It doesn't mean that it's reacting with water. It just means it's dissolving. So that is a physical property. Boiling point. Once again, I'm just changing the phase from liquid to gas. So that is a physical. Reacts with acid. There we go. We've got that word again, reacts. That's a chemical property. Luster, whether it's shiny or not. That doesn't change the material, whether it's shiny or not. That will be a physical property. Supports combustion. Combustion is a fancy word for burning. That is a chemical reaction. Odor, smell. Now think really hard what it really takes for you to smell something. What it takes for you to smell something, that molecule has to go into neuroreceptors in your nose. And those neuroreceptors create a chemical reaction that react with the nerves in your brain. So that is a chemical reaction for something to actually smell. For us to taste something, once again, it has to react with the neuroreceptor taste buds on our tongue. So that is a chemical reaction. And once again, reacts with air. There's that key verb there. That is a chemical reaction. How'd you guys do? All right, let's go look at the next section. Okay, this next section, we want to identify the following as either a physical or chemical change. So I'm going to ask you to pause, put your answers in here. You ready? Okay. Sodium chloride or table salt dissolves in water. That is actually a physical change. We are not changing that we have sodium chloride. Milk sours. Think about what it takes for milk actually to sour. We have to have the bacteria or yeast in there to actually eat up the lactose. So that's a chemical reaction. That is a chemical change. Silver tarnishing. That is with the silver reacting with the oxygen in the air. So that is a chemical reaction. Sugar dissolving in water. We still have sugar. So that is a physical change. An apple is cut. We're not changing the apple. We're just physically cutting it. Wood rotting. Now that is a chemical change because in order to rot, we have to have decay. That means we have fungus and bacteria in there actually digesting the wood. So that's a chemical change. Heat changes water to steam. We're just changing phase. So that is a physical change. Pancakes cook. Do I chemically change what's going on with the pancakes when I go from batter to an actual pancake? You betcha. That's a chemical change. Baking soda reacts, there's that verb again, with vinegar. That is definitely chemical. Grass grows. Now think about what it takes for grass to actually grow. That means we've got to have cells dividing, we've got to have cells creating other cells. That is all a very chemical process. Okay, iron rust. Rusting is reacting with the oxygen in the air, so that is definitely a chemical process. A tire is inflated, pumped up. That's just a physical change. I haven't changed the chemical nature of the tire or the air that's going in or out of the tire. Alcohol evaporating, once again, I'm just going from the liquid state to the gas state. So I'm just physically changing it. I'm not chemically changing it. And food is digested. Oh, digestion is definitely a reaction. So that is a chemical change. Okay, how'd you guys do on that section? All right, let's do the next section. Identify the following as either an intensive, remember intensive properties doesn't matter how much or how little we have, they're just intrinsically, intensively there, or an extensive property. Extensive properties, it does matter how much we have there. So I'm going to give you a second to look at these. You ready? Okay, the density of platinum. Density is intensive. It doesn't matter how much I have, that density is always going to stay the same. Elemental mercury is liquid, also intensive. It doesn't matter how much mercury I have. The volume of a liquid is 45.4 mils. Volume is always extensive. It matters how much I have or how little I have. The pencil has a mass of 18 grams. Once again, that totally depends on how big of a pencil I have. So that is extensive. Aluminum metal has a high degree of luster or shine. That is an intensive property. It doesn't matter how much I have. The beaker can hold a volume of 500 mils. Once again, that's extensive because that totally depends on how big that beaker is. Copper is an excellent conductor of electricity. That's intensive. It doesn't matter how much copper I have, it's always going to conduct electricity. A piece of wire is 14.3 centimeters long. That's extensive. That totally depends on how much copper wire I have. How'd you guys do on that section? All right, next section. Identify the following as either an element, a compound, a homogeneous mixture, solution, or a heterogeneous mixture. Take a minute, fill out this section, and then we'll check it. Okay, you ready? Gold foil. So I'm assuming it's just made out of straight gold. So that would be an element, since gold is an element. Concrete. If you've ever seen concrete broken up, you'll see little rocks and pebbles in there. That's definitely not a uniform mixture. So that is a heterogeneous mixture. Muddy water. Ooh, if you don't stir muddy water, all the bigger chunks of mud go to the bottom and the silt stays floating. So that's definitely heterogeneous. Hamburger. I don't know about you, but my hamburger has a whole bunch of layers. I usually have some hamburger, some onions, mustard, maybe cheese if I want to make it a cheeseburger. It's got layers. So it is a heterogeneous mixture. Cologne or perfume, that is a solution. That is a uniform mixture. Brass, it's copper mixed with zinc. It's uniform. That's a solution. Helium is one element. So it's an element. Sugar water. Well, I've got sugar and I've got water. And if I mix them together, it makes a solution. It is uniform. Limestone. I've got calcium, carbon, and oxygen, otherwise known as calcium carbonate, that makes up limestone. I can write a chemical formula, but it's got more than one element in it. So that is going to be a compound. 14 karat gold. Remember, 14 karat gold is not pure. We mix other metals in it to make it stronger. So that is a solution. If you want pure gold is 24 karat. Okay? Baking soda. Ooh, I've got sodium, hydrogen, carbon, and oxygen. So sodium bicarbonate. You might have noticed that on your baking soda label, it is sodium bicarbonate. We have a pure substance, but it's got several types of atoms in there, so that is a compound. Air inside a balloon. Let's think about air. What makes up air? We got nitrogen, we got oxygen, we got some argon, we've got some carbon dioxide, and various other trace things. They're all mixed together uniformly. Could you imagine if they weren't and you walked across the hall into the pocket of nitrogen? You wouldn't be able to breathe. You'd suffocate. It's a good thing it's a solution. All right, orange juice, fresh squeezed. If you've ever had fresh squeezed orange juice, you know you've got the juice, you've got the pulp, it's kind of chunky. That definitely is not a smooth mixture. It's a heterogeneous mixture. Gatorade, though, on the other hand, is uniform. So Gatorade is a solution. How'd you do? All right, and then last but not least, we're trying to get the symbols for some of the elements. I'm going to give you a minute to spend with your periodic table, put these in, and we'll check. You ready to go? Okay, sodium. Remember, this is one of our Latin ones. The Latin is actually natrium. Okay, F, fluorine. Remember that the U comes before the O. Iron, this is another one of our Latin ones. Ferrum, iron. Tungsten, this is our one German one. W for wolfram. Sb, this is another one of our Latin one. Sb is antimony. Iodine, this one actually works. I. O, this one also works. Oxygen. Silver, this is another one of our Latin ones. Remember, argentum, so Ag. Mercury, this is another one of our Latin ones. Hydra argentum. And C, carbon. All right, how'd you do? Hopefully you did well. We will have an assignment kind of like this, so be ready.